Good morning, everyone. Today, we'll be presenting our project report for correlation and regression analysis. Next. So this is the group members. I'm Arunalisaa, and then we have Mithalina Afiqah and Farissah Najiean, and also Muhammad Aiman. So next. First, we'll be looking at data collection and compilation. So for this part, first of all, we had to measure as criteria for each of the group member. So one of it was the height of each member, and then the second one was navel height, and then arm span, and then we had heart circumference, forearm length, and also shoe print length. So first, all of us measured this, and then after that, we total up the amount for each criteria given. So total of height, total of NH, total of AS, and so on. Everything was in centimeters. And then next, we had to tabulate and compile the data according to the question. So the first one was height and navel height. So, and then the second one was arm span and height. And then the third one was hip circumference and forearm length. And the last one was shoe print length and height. So for all of this, we had to find the XY value where we just multiply the X and Y for each person. So for the table on the first one, the X is height, the Y is NH, the second one, the X is height as well, and then the Y is AS, and then the third one, the X is HC, and the height is FL, and the last one, the X is height again, and the Y is SBL. So we multiply the XY value and then total it up. And then we also find the X power to the power of 2 and Y power of 2. So for this one, we just take the X value, for instance, 165, and then you times 165, so you get X power of 2. So the same applies for all of the tables. So once you find the X power of 2 and Y power of 2, you also add them and total them up. So after each multiplication is done, you have to find the total for all of the columns. So that's all for data collection and compilation. I'll pass on to the next presenter.
Okay, for this part, we're actually going to use the Pearson coefficient for the correlation analysis, which is the R is equals to N multiplied with summation of XY minus summation of X multiplied by summation of Y, divided by square root of N with summation of X square minus summation of X with power of 2 multiply with N and summation of Y with power of 2 minus summation of Y with the power of 2 multiplied by power of 2. So as you can see from the A part, this is the relationship between the height and navel height. So we use all the information from the data collections to calculate by extracting the data and put inside the equation. So here we have like the number is 0.9981, which is kinda closer to 1, which shows a strong positive linear relationship between the height and also the navel height. So between this, we have like 4 different data that we calculate and we put inside the equations. So from the number, the N number, we will do the analysis to see if it's closer to 1 or it is not, because if it's closer than to 1, it shows a strong positive linear relationship. But if it's not closer than 1 to 1, so there it shows a weak positive linear relationship between 2 of the subjects. So I'll pass to the next person. Thank you.
For regression analysis, we perform a regression analysis to find the relationship between dependent variable, which is X, which is Y, and our independent variable, which is x. So here, we have done a manual calculation by using formula, and also we also use Excel to calculate the regression line equation. So firstly, what we need to do is to find the value of x, y, x1, x square, and also y square. And then we need to know the sum up of all of this value. And after that, we need to find the y-intercept, which is A, and also value of slope, which is B. So the equation is here. We need to perform we need to calculate based on this equation for y-intercept, and then we got 15.337 for navel height versus height relationship, y-intercept. And then the value of slope here, we need to calculate based on this equation, and then we got 0.506 for the slope value. So based on this value, which is the y-intercept value and also the slope value, we will get the equation of regression line. So what is the equation explain about is when the x value is 0, which is our height value is 0, the y prime value is expected to be 15.337, and when the x value increase in 1 unit, our y prime value is expected to increase by 0.506 units. And it goes the same with other regression analysis, other relationship. Next. So same goes to arm span, for arm length, and also lastly, the relationship between shoe print length versus height. So that's all for me. Thank you.
So next, I'm going to be presenting about the interpretation of our study. So the data set that we have collected include measurements of each variables of height, navel height, arm span, and head circumference, and also shoe print length. So the analysis aims to explore the correlation and regression analysis for each variable. So the strength and direction of a linear link between the two variables are the main topic of correlation analysis. It gives the correlation coefficient, which is a single number between -1 and 1. So for the formula is used for the correlation analysis is the Pearson coefficient. So next is the regression analysis. However, goes further as it creates a mathematical model to depict the relationship between the variables, usually in the form of a linear equation. So we can forecast the value of one dependent variable using this model. So regression analysis yields more information than just the correlation coefficient. It also reveals the model slope and intercept. So the formula used for regression analysis is the simple linear regression. Next. To conclude the correlation analysis, first one is the height and navel height. So the data presented appears to be a strong indicator of a positive relationship between height and a variable labeled navel height. So the visualized linear regression line suggests a clear trend, and the R-squared value of 0.93 signifies a very strong positive correlation. And then for height and arm span, the information provided seems to point to a higher correlation between height and the characteristic called arm span. A strong positive correlation is indicated by the R-squared value of 0.1544, and the plotted linear regression line indicates a discernible trend. Put another way, the value of arm span tends to grow together with the height. And then for head circumference and for arm length, the results show that the slope of the regression line appears positive. This indicates a positive correlation between head circumference and forearm length. The R-squared value of 0.688 is a strong indicator in concluding a positive correlation. for height and shoe print length, the result revealed that the slope of regression line is also positive. This suggested that there is a positive relationship between height and shoe print length. The R-squared value of 0.3321 indicates a strong positive association. Next. And lastly, for the regression analysis, first one for height and navel height, the formula for regression analysis of navel height versus height is y is equal to 15.337 plus 0.506x. And according to this, the navel height is predicted to rise by 0.506 units for every additional unit of height. In real term, the prediction is that an individual navel's height will rise by 0.506 units if their height increases by 1 unit. For each given height, the navel height may be predicted using the regression equation. For example, if a person is 170 units tall, then y is equal to 15.337 plus 0.506 times 170. So would be their estimated navel height from the prediction. If a person height is 170 units, their predicted navel height would be 100.357 units. Next. And then onto the height and arm span. The regression equation for arm versus height is given as y is equal to negative 13.219 plus 1.063x. So this equation provides insight in the relationship between a person's height and their arm span. The slope of regression line 1.063 indicates that for each additional unit increase in height, the arm span is expected to increase the approximately 1.063 units. So using this regression equation, we can predict the arm span for any given height. For example, if someone's height is 170 units, and add it to the formula of y is equal to negative 13.216 plus 1.063x times 170. So the prediction would be resulting in arm span of approximately 167.491 units. Next one. Okay, and then going forward to the head circumference and forearm length. So the regression equation for forearm length versus head circumference is given by y is equal to 71.273 minus 0.818x. So the equation indicates that for each additional unit increase in head circumference, the forearm length is expected to decrease by 0.818 units. So the negative slope of negative 0.818 suggests an inverse relationship between head circumference and forearm length. So using this regression equation, one can predict the forearm length for any given head circumference. For example, if someone's head circumference is 50 units, their predicted forearm length would be calculated as y is equal to 71.273 minus 0.818 times 50. So if the person's head circumference is 50 units, the predicted forearm length would be 30.373 units. And then lastly, for height and shoe print length, so the regression analysis shows that y is equal to 2.867 plus 0.27x for shoe print length and also height. So the shoe print length and individual heights appear to be positively correlated. According to this equation, the regression line slope of 0.127 specifically shows that the shoe print length is predicted to grow by 0.127 units for every unit increase in height. Next one. So the regression equation can be employed to predict the shoe print length for any given height. For instance, if a person's height is 170 units, their predicted shoe print length would be calculated as y is equal to 2.67 plus 0.127 times 170. So when the person's height is 170 units, the predicted shoe print length would be around 24.457. So this is the predicted value of y when x is equal to 170. So that's all from our group. Thank you.